Are you getting my screen? J3, M2, are you getting my screen? Are you able to view my screen? J7, L9, M6, K8, K0, K9, N3, J3. Can you reply me? Yes, all of you, are you getting my screen or not?
Yes, sir.
J7. Okay. Today we are going to discuss about layout managers. In yesterday class we discussed AWT hierarchy, AWT controllers, and labels, buttons, text fields, text area, checkboxes, checkbox, group list, and choices. And these things we explained with the examples, login form and profile form. Okay, profile form like registration form. I think till that you understand. Now in this today's session we are going to discuss about managers. So we have different layout managers like a flow layout, border layout, grid layout, and okay. What are the layouts we have? We are going to discuss flow layout, border layout, grid layout, and card layout. Okay. First one is flow layout. Okay. First, what is the layout managers we can discuss here? So a layout manager automatically arranges users controls within a window by using an algorithm. So positioning manually the controls on the large windows is more difficult. Java provides layout managers to position the controls. So here the container object has a layout manager associated with it. A layout manager is an instance of any class that implements layout manager. Layout manager is the interface here. So a layout manager is an instance of any class that implements layout manager interface. If no layout manager is used, Java layout manager. Okay, so we have different types of layout managers. Here the layout manager is set by using void set layout layout manager object, and to set manually when object is null. So what is the method we need to use for set the layout? Set layout is a method. So it is return type is void, so we cannot return anything here. So layout manager, we are passing layout manager object here for layout set layout method. So this is if the layout manager, if you create a layout manager to set manually, then the object is null. That means object is null value. So each layout manager keeps track of list of components and stored by their names. Java has several predefined layout classes, which are flow layout, border layout, grid layout, card layout, and grid bag layout. So in this we will discuss flow layout, border layout, grid layout, and card layout. See, first one is what? Flow layout. Here flow layout is the default layout manager. It is a simple layout style linked text editor, like linked text editor. So layout components from left to right, top to bottom. So line by line from upper left corner. The constructors are three constructors we have here for layout manager. The constructors are flow layout. Next one, flow layout with parameter, one parameter, that is int type parameter. Then flow layout with three parameters, int, horizontal, vertical. So we have three constructors here. Default constructor, parameterized, two parameterized constructors. Okay. Right. Here the default constructor centers the components and leave 5 pixels of space between each component. If it is default flow layout constructor means centers the components and leaves 5 pixels of space between each component. Okay, we'll see in the example how each line is aligned is specified. How the value are flow layout left, then flow layout center, flow layout right, flow layout leading, flow layout trailing. Okay, left to right to center to leading to trailing. So this we can perform by using layout. Here the horizontal and the vertical spacing between components is specified by using or means horizontal, V or V means vertical. Okay, we have one example here, flow layout demo. See that the flow layout demo is replaying. Are you getting my screen or not? So now I am going to open our Eclipse IDE. So it contains our example. Because of that example, we can understand the flow layout manager easily. The Eclipse IDE is opening now. Yes, all of you. Are you getting Eclipse? Are you able to view Eclipse IDE? So if you want to understand these programs, just install Java software in your laptop or desktop. So then download Eclipse IDE. Then start practicing all the programs which I have given in the document. The document I had uploaded in your Teams folder, Java ECE, file name is Java ECE. You can download that document file and start practicing all programs, learn the theory. Okay, for your external examinations and for interview also. getting my screen or not? All of you are getting my screen. Eclipse ID screen. The example for flow layout. Okay, so these are the import statement we need to import to implement our project. Control Shift O. If you press Control Shift O is a shortcut for Eclipse IDE to import required statements. Okay, so here we are using checkbox, color, flow layout, font, frame, graphics, label, item event, item listener, Windows adapter, and Windows event. Okay, so here our example is for flow layout manager. See, I created one example here. This is our class name. Our class must extend the frame and implements item listener. Okay, so extends the frame, implements the item listener. Here for displaying message, we are using string message. It is empty now. So here we have 4 checkboxes: C1, C2, C3, and C4. In the constructor, flow demo constructor, we are going to write the code. Okay, so just we are created one label here. Okay, that label displaying message languages, known languages. Okay, here set visible I given true, that means we can view our GUI application. Next, set size 400 width and 400 height. Then set title. Set title. We are setting the title. Flow layout example. Okay, title we are setting. And set background. Background color. Color pink. Background color I am setting pink. And color C equal to new color. We created one color object and that width height side, and say foreground of C. We are setting the foreground. And font F equal to new font. Font is Arial and font is bold and size 10. Okay, next set font F. We are setting the font. We are creating font object and setting the font. We are creating the background color and we are setting that background color here. And we created another object called flow layout. This is important here. This flow layout F1 equal to new flow layout left and 15 with the height. Then set layout F1. We are using set layout method to set the layout. Okay, definitely. Next, we are creating 4 checkboxes here. The first checkbox that is C. Then second checkbox displays C++, and third checkbox displays Java, and fourth checkbox displays .NET. So whenever if you are trying to click on checkbox on C language, so it is going to return the true value. It is C++. If you click on a checkbox C++, it is going to return C++ true. So that's what we are trying to do as a simple application. So to understanding the flow layout manager. Okay, so those are the checkboxes we designed here, and we added the label 4 checkboxes to the frame, okay, by using add method. Next, the checkbox is C1 added item listener for current class. Then C2 add item listener, C3 add item listener, C4 add item listener for the current class constructor. That's what this represents, what current class constructor here. Okay. So for while you are open the layout, so we need, if you want to close that window, means we should write this code. What is the code? We need to write here: add window listener, new window adapter, okay, object. Then inside of that we have one method called window closing method, which contains a window event. Okay, here we are disposing it. If you click on this, it is going to dispose. That is the code we have written here. Okay, after that, so item state changed, item event, that is repaint. Next, paint method contains object. So here we are displaying the message ms equal to current selection is. Current selection is whatever it is. If you select C++ C, then it is going to display current selection is arrow mark and get state true or false. C1 dot get state true or false we can written here. So message current selection is, then G dot draw string of message. Okay, we are drawing the message there. Then 6 comma 18, and message equal to, if it is C, so it is giving arrow mark, this message static message. Then so dynamic value whatever it is, true or false, so we should return it. So how you can get that status means based on the checkbox value. If you click on that, it should return true value. Okay, so C1 dot get the state, we can get to that state here. Okay, next draw string 6 comma 100, here get C2 dot get the state for C++. For Java, C3 dot get state. For .NET, C4 dot get state. Okay, so then draw the string. So that's what we have written the code here for the flow layout manager. So just to save here, press Ctrl S. Next, I created object for this, means if you call this method in the main method, so it is to call the constructor which is available inside the flow demo. Okay, this is our constructor. If it is calling, means all the instructions which are available in this construction going to be executed. Okay, one by one. See, now I am going to run this program. Click on the program, then run as, click on Java application. So now we can see the output here, that layout, flow layout. See, this is our flow layout. This is the window. So languages now. See the see here coding. See languages known. See here label L1 equal new label. This is one label. So label message is languages known. So this what we are displaying here. Next, so set this equal to, that means we can view this, and we have given size for that. And title, we have set the title right, flow layout example. See here we have a title, flow layout example. Okay, title, see here flow layout example. If you give title, it will appear here. Next, select the background color is what, pink. Here background color is what, pink. Next, and the font Arial bold 10 size, whatever font we have given, that is Arial bold, size is 10. Okay, and we have created 4 checkboxes here: C1, C, C2, C++, C3 checkbox contains Java, C4 checkbox contains .NET. See here, checkbox C, checkbox for C++, checkbox for Java and checkbox for .NET. Next, current selection is message label. Here current selection is just text message is okay. After that message c1 dot get status. So already it has clicked here. We have given already we have given here the C is true default. Okay, remaining are we need to set. So now see here C is already clicked, means that means true. C here C is returning true value. Coming to C++, Java and .NET, false. So if I click here, if I selected C++, automatically the data going to be changed to true. Okay, click means true. See here C++ is true and Java is false, right? Now it is going to be changed. Java is true. Click here, Java is true. Then .NET, click here, .NET is true. So this is the flow layout manager. By using this, we can develop this type of applications, right? Yes, all of you, are you understanding? This is about flow layout manager. This is the code we need to write for. This is the code we need to write for developing this flow layout manager application. Okay, right. So don't close here. If you want, you can close, but while you are developing application real time, you can close from here. Okay, because of that it is not going to be hang. Okay, all right, this is about flow layout demo. Okay, next, the next one is border layout. Yes, all of you are getting screen. What is border layout? What is the use of border layout here? Here, the border layout is used for top level windows. The layout has 4 narrow fixed width components at the edge and 1 large area in the center. So the 4 sides are called north, south, east and west. Are you getting? Border layout, borders. We are designing borders here. North, south, east, west. Okay, borders we are going to design. So it is used for top level windows. The layout has 4 narrow fixed width components at the edge and 1 large area in the center. In the center we have some large area. From north side, west side, east side, south side we have the layouts. So that is called border layouts. We are writing borders here. We are designing borders here. Then what are the constructors we need to write for the borders layout template? So we have 2 constructors here. First constructor, that is a default constructor, that is border layout to default constructor. Next one, border layout constructor with 2 parameters. The first parameter is horizontal into data type, and the second parameter into data type vertical. Next, horizontal, vertical are used to specify the horizontal and vertical space left between the components. Here the constructor defined in the border layout or border layout dot center. Border layout dot center. So the constructor defined in the border layout are, we have center, east, west, south and north. So then how you can write means border layout to dot center, border layout to dot east, border layout to dot west, border layout to dot south, and border layout to dot north. We can call like this. Okay. So to add components with this layout, we have add method, and the method like void add method contains two types of objects. First one component object, second one object reference and component reference. So we can see that example here. I'm sharing Eclipse IDE. Layout. See here, what are the packages we need to import here? Control Shift O. So what are the packages we need from the AWT package? Border layout, button, frame, label, text area, action event, action listener. So I created here one class called border demo. That border demo class must extend the frame class. So we have one class that is called border demo. I have created that border demo class extends the frame, implements action listener. So here we created buttons, labels, so text area. So button, three buttons we created, one label, text area, and explain message. Okay, so I created one constructor. That constructor having that all the code implementation code here. Set visible to, that means we can view our GUI application. Next set size, we set the size horizontal and the vertical way, that means width and height. Next we created object called border layout object, border layout b1 equal to new border layout. Okay, and with the height we have given. Then set layout b1, we are setting that layout. Next we created three buttons here, button N and button E and button W. Three buttons, button N equal to new button E equal to new button W equal to new button. So first button displaying the CSC message, and second button displaying ECE, third button displaying trivially. So this is the label, one the label we created, S equal to new label. So it displays border layout. Okay, this display border layout message inside the label. Next we created one text area object. This we creating one text area box here. So in that box we can display the message. Okay, next we are adding border layout for buttons, N button, S button, E button. Next W button for label, yes, and TA text area. So for these three we have set the layout here, and we are displaying N button, that is CSC in the north side. Then S means border layout in the south side. E button EC in the east side. Next W triple E in the west side, and TA means text area in the center. So we created border layouts in this way. So we have added for action listener for the current class constructor border demo. Then action performed, action event. So if you are implementing action listener interface means, so now it returns the disturbance. Sorry for the interruption. We have power problem here. Okay, let us continue our session. So we have a border layout here. So I think you understand this border layout, right? This is the coding you need to write for all border layouts. If you want to design border layout, you can design in this way. Okay, right. That's all about border layout. Next, we will see grid layout. Next, third one is what? Grid layout. Grid layout means this grid layout components in the two-dimensional grid. Okay, the number of rows and columns are specified while creating an object. The constructors are for the grid layout. What are the constructors we can use in our program is grid layout or default constructor, then grid layout 2 parameters, grid layout 3 parameters. Okay, is it recording or not? Okay, right. Are you getting screen right? Here the grid layout component in the two-dimensional grid. The number of rows and columns are specified while creating an object. While creating object, we can specify number of rows and columns we need. So for grid layout, we have these constructors: grid layout default constructor and grid layout parameterized constructor. Grid layout default constructor creates a single column grid layout. Grid layout 2 parameters constructor, that is int rows and int columns. So that creates a grid layout with the specified number of rows and columns. Next one, grid layout with 4 parameters. So those are int data type, int rows, int columns, int horizontal, int vertical. Okay, so this grid layout 4 parameterized constructor create a grid layout with the specified number of rows and columns, and spacing between components is specified using horizontal and vertical. The rows equal to 0, that means it allows unlimited length columns. If the columns equal to 0, that means it allows unlimited length rows. Okay, next, this is the grid layout program. We can see this program in Eclipse IDE so that we can run that program there and we can understand grid layout. I am sharing our Eclipse IDE screen here. Grid layout demo is our example class. See what are the import statements we need here, what are the packages we need here. AWT package that contains the all classes, Ctrl+Shift+O, we can see all the imports here. So we created button, font, frame, grid layout, and Windows adapter and Windows event classes. So here I created one grid demo that extends the frame class, and here I declared static final int n equal to 4. That is final, we can't change the value, and it is storing in main memory because it is static. So here we have grid demo constructor. default constructor, we have written all the code inside this constructor, because so that we can run the program while you are creating object inside the main method, right? So we are setting the layout for the grid, set layout to the frame. So that is new grid layout, okay, that contains 4 parameters, okay, into, see, that's what we explained, right? 4 parameters. And 4 parameters for grid layout: rows, columns, horizontal, vertical, right? Rows, columns. How many rows? 4 rows. How many columns? 4 columns. And horizontal and vertical. So set visible true. You know about this. Next, set size, width, height, 400, 400. Set font for the letters. So new font of sans serif, font italic, and size 24. So see here, we have two for loops. For int I equal to 0, I less than n means 4, I plus plus. 0 to 4, 0 to 4 means 0, 1, 2, 3 means 4 times it is going to be repeat the loop. And for int j also, j equal to 0 to n, n means here 4, less than 4 means 3. So 0 to 3, 0, 1, 2, 3, 4, 4 times it is going to repeat the loop. First in into k, I into n plus j. Here I means first 0, n plus j, n is 4 plus j, first one k value is 0. Next k value is I equal to 1. Next n 4 plus j is 1. In that way it is going to repeat till the button is creating. How many buttons? So till 4 buttons we are going to do. The adapter created. That means if you are here, you are not implementing any listener classes, listener interfaces here. So just we are writing the Windows close method to disposing. While you are open the window, we need to close, right, with the into box. So method, it contains the dispose method. So using this we can close the window. So void main that contains the grid demo. Okay, that means we creating a grid demo object here. Okay, so that we can run this program. So grid demo const three, 4, 5, 6, 7, 8 grids we have created based on this for loop. Okay, are you getting? K value is 0 first for, second 1, third 2, 4, 3, fifth 4, sixth 5th, sixth we have fifth, sixth, 7th. Are you getting? So these are the grids we have designed here. Number of grids, 8 grids we have created. So we have used for loop for writing this. So for designing these grids, we have written the code. Grid 24. Okay. All buttons. created add value k value. Okay, right. That's all about this grid layout. This is the program you need to understand for writing the grid layout. Card layout manager. So this layout manager stores several different layouts. This card layout manager stores several different layouts. So each layout can be thought of as being on a separate index in a disk that can be shuffled so that any card is on top at a given time. So for card layout, we have two constructors here mainly. The first constructor, as you know already, we have default constructor for every layout. So this card layout default constructor creates a default card layout. The next card layout constructor is two parameters constructor. So those two parameters are into horizontal, into vertical. So this constructor, this parameterized two parameterized constructor allows to specify the horizontal and vertical space left between components. All individual cards by panel. We can see panels here. Here all the individual cards are held in an object of type panel type. Of type panel, that is called main. Next, and all the cards to the main panel for which the card layout is managed. Panel to the window to access individual cards provide a panels to the main card. We have add method. The syntax so each individual panel is given a name. Okay. Last, next, previous show. First, having parameter container. Last, and next having parameter container. Previous having parameter as container. Show method that contains parameters are container and okay. Show method display card whose name is passed as name. Okay, the show method display card whose name is passed as name. This is the example card layout, card demo. Here we are implementing action listener interface, comma mouse listener interface. We have checkboxes C1, C2, C3, and C4. For MTech, we have checkboxes for C5, C6, and C7. Panel disk. So panel P1 and P2 for cards, panel disk for deck, panel deck for deck, and card layout CL buttons, two buttons B1 and B2. Inside the constructor, we have written the program. We set the size 400 width and 400 height. Then set visible true. Then set layout. Then we created buttons B1 equal to new button, button B2 equal to new button. First button is BTech, second button is MTech. So we added that buttons to frame. Okay. Next CL means a new card layout 5, 5. Card layout CL equal to new card layout of 5, 5. Next disk panel disk deck equal to new panel. Next panel deck dot set layout CL means we are set main panel layout to the card layout. Here we created 4 checkboxes. Checkbox C1 equal to new checkbox. In the checkbox we have CSC true. Next checkbox C2 equal to new checkbox. Checkbox C3 equal to new checkbox, that is triple E. Checkbox C2 equal to new checkbox, that is ECE. Checkbox C4 equal to new checkbox, that is C4, that contains mechanical. Next we are creating panels per panel P equal to new panel for the first card as panel. So P1 dot add of C1, we are adding and C3 to panel 1, C4 to panel. Next we created another checkboxes C5, C6, C7. So here new checkbox neural networks. C5 is neural networks true. See another checkbox C6 is digital image processing. C7 is machine design. Next we created another panel P2. P2 equal to new panel. This is for second card as panel. Then we are adding checkboxes to second panel P2. C5 and C6, C7 checkboxes we are added for panel 2. Next adding panel cards to main panel. Here deck is the main panel, right? So deck dot add of P1 of BTech, deck dot add of P2 dot P2 MTech. So the main panel disk to frame we are adding here by using add method add of deck. Next B1 to add action listener of this, so B2 dot add action listener of this. Next add mouse listener of this. Now we have that methods, right? To mouse. So having pressed mouse clicked mouse and pressed we have and mouse public mouse event means into its logic within the method action model that contains action of get so I'm presenting Eclipse here. I think you are able to view this Eclipse IDE. See here, we have the import statement. So this is for right. So Here we required to import a button, card layout, checkbox, flow layout, frame, panel, action event, action event, mouse listener. So these we need to import java.aws for writing our program. See, I created one called demo class. Our demo class, the frame class, and implementing a 2D interface that is called action listener interface. Or predefined methods. For implementing this means we must implement that methods also, predefined methods also regarding to action listener interface and mouse listener interface. See, we created here 4 checkboxes: C1, C2, C3, C4 for BTech, and C5, C6, C7 for MTech, and panel desk, panel P1 and P2, card layout C1, button, 2 buttons P1 and P2. So inside the card layout construct, card demo constructor, we have written the all the code. We set the size 400 width and 4 now created one card digital image now we that is you know after so mouse clicked, nothing had written. Mouse entered C1 dot first day. Next was mouse exited C1 last day. So public void mouse release, mouse release we did not return any logic, and for public void action performed for action event, so that we need to write some logic here. Okay, so if a action event get source w equal to v1, that means it returns the clicked button object. That's of data. So we are creating object for card demo d equal to new card demo. That means we are calling the constructor so that we can execute all the program here. Okay, in the main method. So that see here, now I'm going to run this program. Then run as Java application. And MTech. Okay. BTech, CSE, ECE, EEE, Mechanical, for MTech, Neural Networks, Digital Image Processing, and Machine Learning. So if you are mouse dragging here means mouse pressed, mouse released, mouse pressed, mouse released. Okay. So if you drag here in this way, we can display. So this is what we have written in this program. I think you understand, right? Like that's all about this program. Okay. All right, we can close from here. Okay, if you directly closing here means you will get the hanging problem. So you should close from here console. You can clear the trademark, click on trademark, and you can clear here. Okay, that's all about card layout. Okay, till now we have seen this all the theory and examples for layout managers. That's all about the layout managers. So we have discussed the layout managers of flow layout, border layout, grid layout, and card layout. Also, the last one. So if you completed the limitations of AWT, that's all for Java syllabus. Okay. So we are going to complete our Java syllabus if you are complete the limitations of AWT. That is only is the pending. So we are going to complete that also now. Okay. For the next classes, we are going to discuss all the revisions. So what are the important topics? Those I am going to discuss. Okay. All right. The next topic is limitations of AWT. What are the so this is for developing window-based GUI application, we are using AWT or applets, right? So instead of that, do you have any technology? Advanced technology means we have Java Strings programming. Java Strings programming. So what are the differences between that Java Strings advanced technology and Java AWT? So see here the limits of AWT. Are you getting my screen here? Okay. See the limitations of AWT. So the AWT defines a basic set of controls, windows, and dialog boxes that support a usable but a limited graphical interface. We have limited graphical interface in AWT. And one reason for the limited nature of the AWT is that it translates its various visual components into their platform specific means that the look is defined by the AWT components use native code resources. They are referred to as AWT uses or even act anywhere. Second, the not be technology for AWT and applets, that is called Java Swing. Platform depends. Because of that, write once, run anywhere. The slogan of Java is going to be spoiled, right? So that's why the Java Swing program came. So the Java Swing components are platform independent. So the Java AWT components are heavyweight, and it's taking so much of space. It is making our process slow. So Java Swing components are lightweight. Okay, and AWT does not support pluggable look and feel. Okay, it doesn't support. If you want to add some more plugins to develop different types of AWT application, it is not possible because AWT doesn't support the pluggable look and feel. But coming to swings support pluggable look and feel. We can import. So AWT provides less components than Swing, but Swing provides more powerful components such as tables, list, scroll pans, color choosers, okay, tab bid pan, etc. Next, coming to AWT. So AWT does not follow MVC. MVC means modal view controller process. So AWT does not follow modal view controller process, where modal represents data. Modal means what? Data. View represents present, and control acts as the interface between modal and view. Are you understanding what is MVC? Modal view controller. That modal means what? View means what? Control means what? Modal represents the data. View represents the presentation. View means presentation. Controller acts as the interface between model and view. So that means we are performing different operations on data, means model, and we are displaying the data through the presentation, that is view. So that is called the modal view controller, MVC. So here AWT doesn't follow MVC. Coming to swings, swings follow modal view controller. Okay, so that's all about today's session. So syllabus is completed till here. Okay. I will prepare questions. I will post in our teams. Okay, in Java team folder. So I have uploaded already a document called Java EC. You can download and please be prepared. Everything available in the document only. Okay, and I will give some more important programs for the interviews. I think you know already palindrome, Fibonacci series, prime number, already in okay. All right, please download the Eclipse IDE, start practicing that programs in Java. All right, any doubts? Okay, coming for classes platform